Set Print. My name is Jonathan Osterman. I'm a learning specialist with the Van Andel Institute for Education, and I'm super excited to be talking about how we can get started with 3D printing in our classrooms today. A topic that I've been super passionate about for about the last year, and really excited to dive into that together. So before we get going, just a couple of details. The webinar is being recorded today, so anything you see and hear and love here, please share that with your colleagues and friends. The other way you can share that out is through a handout that is going to be shared in the chat with you. I encourage you to grab that handout, make copies of it. If you'd prefer a Spark Notes version, you can find everything I talk about in there. And then finally, Robin is going to be in the background helping out today. Would you like to say hi, Robin?
Absolutely. Hi, everybody. Thanks for joining us. Happy fall.
Fantastic. She is there to help with anything that pops up along the way. If you got questions that I can answer later for you or that she can answer in the moment, feel free to send those to her through the chat. Our webinar today is sponsored by the Inquiry Outpost. The Inquiry Outpost is for those curious educators who are interested in finding inquiry-based science resources, building essential skills across their curriculum. All of these are practical and time-saving resources that can help you promote more curiosity, creativity, and critical thinking in your classroom. Highly encourage you to check that out. I'll be showing a few images and resources that come from that outpost today. And for being with us, you get 20% off at your checkout. So definitely head there and check those resources out. So let's dive into our topic. We're talking 3D printing today. So we're going to start with the why of 3D printing. I feel like it's important to set the stage there, as if you're embarking on this journey, you're already in it, you're investing time, money, and effort into learning this new technology. So we definitely want to have a good basis for putting our effort and energy there. Number two, we're going to take a look at understanding the 3D printing workflow. This is going to be a flyby in this 30-minute webinar. So try to give you some comfortability with that process and overview of that. And then we'll take a look at some considerations for integrating this into your classroom, some strategies to do that effectively. And finally, I'll leave you with some high-level project ideas, no matter what grade level you're at, some ways you could start to implement this either on your end as a teacher or start to have students working and printing with 3D printers. So to get us started, I'm guessing we got a variety of grade levels here. So I'm just curious where you are at in your 3D printing journey. On a scale of 1 to 4, I'd love for you to rank yourself. Are you just curious? You maybe don't have a printer yet. You're just getting started with this or thinking about this. You have a printer, but you're not using it. Maybe you moved into a classroom and you inherited it. You have printed a few things, or you've been printing for a little while, but you're not quite confident in it yet. Or maybe you're a number 4 and your house is 3D printed. You've got 3D printed gizmos and gadgets everywhere. Myself personally, I'm in the 3 area. Like I mentioned, been doing this about a year now and loved it. Love trying new things, love experimenting, and it's become just a highlight of my work. So that's kind of where I'm at. Robin, how are we looking at that poll?
We are good. All right, so we have 38% at just curious, 31% at printed a few things, 25% have a printer but not using it, and 6% their houses are 3D printed.
Nice. All righty, we've got some heavier on that just curious and maybe newer side. That's perfect. That's a great spot to be in. And those of you who have done this a little bit more, hopefully you can get some practical ideas as well to walk away with today. So let's move right along, right? This image might be a little bit nostalgic for some of us, right? This 3D cell project, whether you are a science teacher or whether you did this in school, I feel like most of us got this experience, right? And to this day, the moment anybody says mitochondria, you go powerhouse of the cell, right? Thanks to a project like this. This project was great, awesome. I think I was in the styrofoam ball category that I used to make this project back when I was in middle school. But man, styrofoam balls are expensive. And I'm like, why did my parents let me do that? But I want to show you, an updated version of this project. Let's take a look here real quick. All right, so reimagining our 3D cell, we can design and 3D print this. And you might look at this and go, that's cool, that's just a substitution, John, right? We're just flip-flopping materials a little bit different. But as we're gonna go into it, I'd argue that a project like this 3D drafting all the way to printing adds a little bit of a new layer onto our traditional styrofoam ball cell model. So let's take a look at some of the benefits of maybe engaging in the project in this way versus our traditional way. So number one is building success skills like collaboration, communication, creative thinking, critical thinking, curiosity, perseverance, and self-direction. I think 3D printing has the power to enhance all of these skills. If you look at the picture on the right, this is from one of my programs. Students were designing cities of the future. And if you look right in here, there is a 3D printed piece there. A student was working on this project and didn't quite have the materials he needed in order to make this project the way he wanted. Power lines weren't staying up. They were trying to run power lines. And at the time, we didn't have 3D printers. This student had a 3D printer at home and asked me like, hey, John, can I go home, print this, bring it in and apply it? I said, sure, why not? He designed this power line and a couple others that wound up running through the city. And so through that, we see creative thinking demonstrated as he had to find a new material and come up with a new way to do this. He had to communicate with me and his partners his plan. He had a lot of self-direction here, right? Went home and did this on his own time. I did not ask him to do that. He asked me and it turned out awesome, right? So we can build really great skills through something like 3D printing. Number two, 3D printing is an awesome cross-curricular endeavor. And so the picture in the middle here is a 3D printed protein with a virus in the background. We've got researchers nearby that work at the Van Andel Institute for Research, and they 3D print and model proteins and amino acids and things so we can see those on a larger scale. So in that, we've got design thinking, color theory, we're documenting this process, we're symbolizing things. And so we can find the intersection of various disciplines through 3D printing. This isn't just a science classroom or a STEM classroom thing. We can bring history in this. We can print artifacts off. We can bring our microscopic and our macroscopic down to a scale that we can visualize and handle and see and model this. Math, geometry is all woven into this intricately. So we can tap into a lot of different disciplines through 3D printing. And finally, for those of us who are in the STEM or science space, right, this weaves perfectly into our next gen science standards. You're going to be able to hit on all of your engineering standards through 3D printing. And 3D printing is just a wonderful display of the process of engineering design, starting with a problem, coming up with a plan and building that, testing it, seeing how our print works, how it fails, and continuing to refine that until we have a product that is useful and awesome, right? So we can hit on that awesome design thinking through these printers as well. So those are some really great reasons to use this, to implement this technology. I'd like to just take a quick moment and see what you're thinking you'd like to use it for. What excites you most about 3D printing? Is it the ability to creatively express? Is it the ability to real world problem solve? We can design and print tools we can actually use. Is it student engagement, cross-curricular potential, hands-on design? There may be something outside of these bounds, but when you look at these five, what strikes you as most exciting with this technology? How we doing, Robin?
I'm going to get about 5 more seconds. They're still rolling in a little bit.
Perfect.
All right, closing it down. All right, well, all of them are exciting to people, which is great, but let's at the top, the leader, 41% hands-on design, followed by 24% student engagement. Those are our top two.
Perfect. Those are two of my favorites as well. I'm so glad to hear that. And I figured all of them would have some interest, right? Hands-on design, we're printing things, we've got new materials that can actually be used in the real world. So let's dive into that 3D printing workflow. There's 3 main steps to creating a 3D print. Like I said, this is going to be a high-level overview of those 3 steps. The first phase is designing your thing digitally. The second phase is slicing that and giving the printer instructions on how to print that off. And then the third phase, of course, is printing it. So let's dive into how we can do each of those phases. First phase is designing. When I'm working with students, particularly kindergarten through 8th grade, and this definitely scales up to high school, I'm relying on a tool, Tinkercad. This is a free tool. The classroom aspect of it is totally free. Everything's free. There's no paywall, no freemium, and I love this tool. So we're going to transition over and just take a look at Tinkercad and how it works briefly, but this is a great tool to get even you started doing your own designs. So here's what Tinkercad looks like. I created my free teacher account, and I can kind of see my dashboard over on the left. I've got the home classes. These are my designs here. I can organize those into collections. I've started to do that a little bit. We've got tutorials. There's challenges they offer. We can learn. We can find what other teachers are doing. But let's just go into a design. Let's create a new design here, and just look at how Tinkercad works from our students' perspective. Tinkercad is really just combining and working with shapes. It functions off of a shape and hole system. So I've got my shapes on the right side of the screen here. I'm going to drag and drop that in there. I can tinker with those dimensions. If I want to make it bigger or smaller, I'm going to leave it for now. Let's say I want to make a simple rocket ship. I'm going to pull in this cone here as well. And what I'm going to do is just make sure those units match, 20 by 20. And I can start to move these things and bring them together. I can move my view pretty easily. By the way, Tinkercad works really well on PCs, Macs, iPads, whatever devices you have. So I've put those two together, and then I can combine them. I can put them into a group and they become one object, right? From there, the other thing I can do is put holes into things. So this one's a hole instead. I'll just shrink that down real quick for demonstration's sake. And we'll just merge that in here. And if I go bam and I group those together, right, I can create a hole in there, right? So simple drag and drop design, very easy to grasp, very easy to do. We can delete, start all over. And it's a really fun way to just experiment with shapes without having to have too much technical knowledge on how to combine and create 3D designs. All right, Tinkercad has a really great class setup as well, I'll show you. So here's my class that I got going on right now. I actually was able to make all of these for my students so they can log in super easily. They get their login code. I did all of that work, boom, they're in. I can create activities for them. This one, students are going to be designing a license plate for a vehicle design that they're working on. And so if I click in here, it's going to give them the template that I created. I made this license plate, and then they get to remix that. So they can click tinker this, they'll remix it and make their own. So I can do that with pre-made things that I find on the internet. I can use other Tinkercad designs. So that's a little bit about the design side. Once, if you're looking for more advanced design, Autodesk, who creates Tinkercad, also has Fusion 360, another program that has some free features. This might be for your high school level or higher, more advanced designs, or for you personally. And Blender over here is a more artistic take on three-dimensional design. If you've seen the movie Flow, that movie was actually made completely on Blender, but we can translate those into 3D prints as well. So once we've designed something, we are going to download it from Tinkercad as an STL file. And that STL file, we need to turn into printable instructions. So we're going to use a program like OrcaSlicer or Bamboo Lab, right? So just to show you what that looks like, if I go back to my designs, let's pick my registration. I would do export, and I'm just going to download that as an STL file. It'll download. Great, and we're going to move over to my slicer. This is another free program. I primarily use OrcaSlicer. You can download it for free. It's linked in the handout. Another one you can use is called Bamboo Labs, another free program that you can use. But from here, we're just going to go ahead and we're going to import that file. Maybe if it's going to give me the option here. No, it's not showing my bar. So we'll adapt here. I'll just show you one that's already done. We'll open this one that I already have processed, right? Here's some ducks I was 3D printing, some fun 3D ducks for students. We were working on a project. And once I get in here, I'm going to prepare it and I'm going to slice it. And once I click this slice button up here, it's already done on this one, it is going to slice that out and it's going to tell me how much filament I use. This one uses 74 grams. How much that costs. It's not showing that for this one right now, but usually it tells me how much that print is going to cost, and then it's going to tell me how long it takes to print that off. So this particular print is 4 hours and 20 minutes total. You'll see the green in here. Those are called supports. So 3D printing can't happen in mid-air, and your students and you will learn this as you print, and your slicer is going to give you errors. If I were to try and slice this without supports, it would say, hey, I can't do this. There's things hanging in mid-air. So I simply add supports in. There's a selection over here, support, and I can turn that on or off. And it automatically adds those supports, so I don't have to worry about the technical side of that. Those supports will show up and then I can peel those off once the 3D print is done. So that's what slicing looks like. Once we slice, we're gonna click print plate. For this one, I am going to export that file as a G code. So I'd export that, and that G code is going to be my final print file. From there, depending on your printer, you're going to transfer that file with a USB drive or an SD card, or if your printers are set up wirelessly, you can definitely send that directly to some printers and print it off from your computer. So finally, we print, and here's that duck file I just showed you. We'll show you a time lapse of those printing. So this is that 4.5 hour-ish print in about 36 seconds. We're using a Bamboo Lab printer here, and you can see those build up. You can see the duck portion is this nice smooth portion, and those supports are showing up around wherever the angles and degrees get too great for that 3D print to kind of stick and hold on. So these prints have a lot of supports, and I wanted a lot of supports in this case to demonstrate to some students the limitations and drawbacks of different designs. So there they are, all finished, ready to go. We'll take those off the plate and they're ready to use. So let's take a quick look at some considerations when you're looking at doing this in your classroom. 3 main things I think to think about as you look at this technology. Number 1 is the amount of time it takes, not only to prepare, but to print things off. Number 2 is technical knowledge. I've given you a really grand overview of how this process works, but there is some technical knowledge in order to create successful prints. And then finally, cost. We can't forget the cost of the filament. Filament's called PLA that we were using in this case. And so how much that filament is going to cost, how many prints we're going to be running, right? So let's look at some ways we can work within some of those barriers. So number 1, with time, start small. And this can look like starting even on your end. For me, I started just printing things that I thought I would find useful in class, models that I could let students interact with, things that I could use in my curriculum to demonstrate things that I wasn't able to do before. Number 2 is print request forms. I've built print request forms, so I'm not printing everything students bring to me. They have to have a justification for why they want to print something. Or if we're working on a project together and we're working on iterations, maybe a print failed, they don't get to print a new one until I have a good justification of what they've changed and why they need to print this again. I do this through Google Classroom and a Google form, so that's a really awesome strategy to use. And number 3, instead of designing from the ground up, make sure you're having kids or yourself remix models. At the end here, I'll show you some sources where to get other 3D models from, but make sure you're not reinventing the wheel. There's a lot of 3D libraries and 3D models out there that you can just use and glean from. And then finally, some 3D printers allow you to do remote printing, like I mentioned, sending it wirelessly. So I don't recommend letting the printer run without you being in the building, but maybe you want to become friends with, the after hours people in your building, those janitors or other people who are sticking around, maybe there's sports going on, and you can make sure that somebody's there to monitor or check in. A lot of 3D printers will have even some AI built into them that'll stop prints when they go awry. But 3D printing does use heat. So if you're going to let a print run while you're not there to monitor it, I would recommend having somebody around to check in on those things. So definitely look into some options there. Technical knowledge. I've used AI a ton for this. I use ChatGPT or Gemini. I plug in my printer specifics. I plug in the software that I'm using. And for example, I was trying to print wheels, round wheels, and they were printing with little bumps all over. And I said to ChatGPT, here's what I got. It's not printing smooth. What settings should I tweak? You might have seen in the slicer, dozens of different settings. It told me what settings to modify, printed my wheel again, bam, it printed perfectly, nice and round, solid, good to go. So use AI to your advantage here. All these programs, all these slicers come with default profiles based on the printer you're using. So don't worry about tweaking it too much. Just start with the basics, see how it turns out, and go from there. I am blown away at how many students already know how to do this stuff. They've got a printer at home. They know more than me. Identify those kids in your classroom. Maybe elevate them, make them a student expert in the class, somebody you can go to, somebody others can go to for that technical knowledge. And then this one's just an awesome strategy in general with engineering design, but document your fails. Keep the failed prints. Don't recycle them. Don't throw them away. Put them on a pedestal. What went wrong with those? How can we fix that next time around? So document those fails along the way. For money, just so you know, a simple setup is going to be about $400 to start up. I linked a FlashForge printer in the handout that runs at about $299 right now. They go up from there. Filaments like $22 a roll or so. Amazon has some great deals on that too. I linked those as well. So that's the cost of one printer. Those ducks I saw I have seen the cost before. They're only like $1.20 to print all 6 of those in terms of the filament they use. So in terms of an actual print, a small print, they're not terribly expensive to print. Build a print economy in your classroom. Maybe for a certain project, let's say you're working on a cell project, maybe your kids have earned enough equity in your class in order to pay to print something off, to design and print something for that project. So use 3D printing as an incentive in your classroom for engagement and behavior and other things. Donors Choose is a really cool website for teachers. Can't hurt to throw what you're looking for up there. You might need to check with admin and things before you throw that up there, but that's an open source for you to be able to look at what you want, share what you want with your community, and have people donate to your cause. And then finally, check out local maker spaces and libraries. I've met a number of people just as I've started to do this and participated in my local maker space that are willing to bring their 3D printers to you. If you don't have the capacity, they will loan them out. So get to know those people, do some networking in those spaces and see how you can partner with them to bring down the cost to run this perhaps in your classroom. All right, let's talk project possibilities for just a little bit here. So at the elementary level, I love just getting started with 3D printing and making name tags. You can see in the bottom there, simple name tags. Maybe at the beginning of the year, we're getting started on this journey. Teaches the fundamentals of Tinkercad, dragging and dropping, connecting things without gaps. So just a really cool project that can allow them to customize a little bit their locker, maybe a backpack tag. You need to identify backpacks or their desk. Story symbols tying into ELA here. Maybe you're reading a book and you want kids to represent a theme or a character or a setting in that book. What can they print off that's going to help maybe build a scene for that book? Math manipulatives. Maybe this is you as the teacher printing your own manipulatives. You're working on fractions and you want to print some fraction blocks off. Maybe you want to have students design math manipulatives that they could use to help solidify their understanding of a particular concept. So again, these projects don't have to be things that the students are always creating. They could be things that you are creating to enhance your teaching and your lessons. At the middle school level, I love this idea of like STEM jewelry. We create something, maybe an earring, or maybe it's going to be a necklace. We could build circuits into that. Can you make it light up? Can you embed a battery and a small circuit into it so we can weave those concepts together? I've partnered with my local museum recently on a summer camp we were running, and we had students print off museum artifacts. We were able to find 3D files, or we were able to find fossils. We printed those off, and we had students create a historical exhibit around those artifacts. It really brought that to life, giving them, it wasn't a real artifact that dated way back, but they had a physical model to kind of construct this around. They got to pick that, what we printed off. And then custom board games. Again, having students design them or you yourself designing them. This picture down here on the bottom is a couple of kids playing a game that I designed this past summer, and I 3D printed parts modeled after the Settlers of Catan. Maybe you're a Settlers of Catan fan and you want to print your own game pieces there. But I labeled these with different habitats, printed some game pieces for the kids, and came up with some simple rules for this game. We were exploring predator and prey relationships through there. At the high school level, this is a 3D balloon car that I've started to design. It comes in 3 parts, and I've embedded magnets in between, so we can test different variables. What's going to make our 3D car move faster or slower, travel in straight lines or curve. Something important to note with 3D printing too is that I've used non-3D printed parts here. So how can we embed those into this? Not everything makes sense to 3D print. So how can you use materials that you already have and combine those with the 3D printing process? As I mentioned already, printing proteins for chemistry, biology classes, we can print molecular models off to help us visualize the unseen a little bit more. I love the idea of this project of creating assistive devices in the classroom. Maybe there's students in your class or people that you're familiar with that could use some type of assistive technology. Maybe the students are finding these in pre-made files. Maybe they're designing their own assistive technology, but really engaging high schoolers in that design thinking, problem solving process. So some fun project ideas that hopefully you can roll with. There's all kinds of things out there, but these could give you a start in your classroom. Some resources that are worth knowing about if you're looking for 3D prints. NIH 3D here is the National Institute of Health, and there's a screenshot here, right? We can see pollen. They've got 3D models I can download and print of pollen or of viruses or of other biological microscopic things. NASA 3D, super awesome, a library of asteroids, landing spots where previous missions have landed on the moon, all models you can download and print. Printables and Thingiverse are for the most part free 3D printed designs that you can download and print off. Thingiverse up here has a way to filter by lesson or topic, so you can use that filter to find relevant prints for your classroom. And those models can all be imported into Tinkercad, and you can work with them and modify them to fit your needs. So definitely check out those places so you're not reinventing the wheel. All right, that about wraps us up for today. I just want to call out, if you like what you heard here, we gave that 10,000-foot view, but get in touch with us. I'd love to talk to you more about this topic and how you could integrate this into your STEM classroom or into your school in general. We've got Flex PD offerings and immersive workshops that we'd love to bring to you to enhance your makerspace or enhance those skills through technology like 3D printing. Finally, we hope that you'll join us next month for our upcoming webinar, STEAM Powered Learning, 5 Fast Tracks to Creative Classroom. That's going to be on Wednesday, November 12th, same time, same place, 4 p.m. to 4:30. We look forward to seeing you there. With that, if you have any questions, don't hesitate to reach out to me. I would love to answer your questions and to help you further your 3D printing journey. Until next time, thank you and have a great evening.